IP over everything.
Ready to go?
Yeah. Should we start?
Good morning, everyone. This is 9:30, first session on Thursday, and the first formal work group meeting for SNAC. SNAC stands for Stub Network Auto Configuration for IPv6. Is it better? Oh, yeah, it sounds better. Good morning again to first SNAC work group meeting. By now, you are familiar with the IETF policies, especially pay attention to understanding IPR and code of conduct guidelines. You are required to wear mask all the time. That's a good sign. Everybody is wearing mask,
Okay.
and you're familiar with Meet Echo as soon as it comes back.
Okay.
It's coming. It's coming. I do not have controls right now.
Yeah. Yes. Well, I cannot.
Uh,
Both of us cannot.
yeah,
click on it.
So you're not even in the meet echo of the chairs. You
both of us are on IETF. Yeah, it's stuck. Do we have USB connector for internet? For Ethernet?
No.
This one's on two, yeah.
Ah, okay.
You're in?
Okay, let me.
I'm still struggling with the
Okay,
idea.
let me share this.
Mhm.
The
Next
slide
time.
there. Okay.
Yep. So we were on Meet Echo usability slide. You guys are familiar with it. Please make sure you are in the queue before you come to the mic. And also, this is a sign-in tool for Blue Sheets, so definitely sign in. Next slide, please. Here's our agenda. This set of slides followed by first presentation from Ted on stub networks. Second one, Pascal's prefix registration. And we will have plenty of time to talk about next steps and these two documents. So I encourage we will do most of the questions related to the document as the presentations go along. And then any general question for the work group, we can delay it to later on. That's next slide. So this is the first SNAC meeting for those who haven't followed the progress from BOF to today's meeting and on mailing list. This work group will work on connecting stub networks to infrastructure networks, focusing on the mechanisms for addressability, discoverability, and reachability. We have GitHub already set up where you can do issue tracking, but we intend to use mailing list for most of the discussions. We have two milestones in mind, focusing on the basic functionality of stub network connectivity, and then we will look into some extended services. So Ted, you're ready to go next.
Okay, first of all, thank you to our AD and to the chairs for making this happen. This has been a long time coming. Cannot hear? Oh, that's a shame. That usually works poorly because I tend to wave my hand around and then you can't hear me. So let's not do that. Okay, so we've had a number of discussions about forming the working group, and that was based on some ideas that already existed. So I've had a document that's been lying around. I've been trying to figure out how to publish it for a while, and so that served as the starting point for what I hope will be the first document that the working group adopts. Next slide. So this document, the goal is just the basic stub network functionality. We have two main items in our charter. One of them is basic functionality, so we're not depending on infrastructure support. We're not requiring changes to hosts on infrastructure. And then depending on the target type of stub network, we may require changes on the stub network. And the goals for the document are to explain how hosts on infrastructure and stub can discover each other, and how they can initiate communication with each other, and also how hosts on the stub network can initiate communication with hosts on the internet. We don't particularly, certainly in the initial document, we're not too concerned about allowing internet hosts to establish communications with stub network hosts. Next slide. So the original document was actually basically just the whole thing. And that meant that it had both the basic use case and the sort of integrated with infrastructure use case, but it didn't actually have a lot of detail about integrating with infrastructure. So what it had was, how we maintain a usable IPv6 prefix on adjacent infrastructure. And the idea there is that the adjacent infrastructure link may not actually support IPv6. And in order to accomplish what we need to do without doing bridging or network address translation, we kind of need to use IPv6. So if the adjacent infrastructure doesn't have a prefix, we have to provide it. And so there's actually, in the original document, it just basically described how that was done. It didn't give a state machine or anything like that. It described how to do SRP registration for the stub network. The assumption was for native 2.15.4 network, we really don't want to use multicast, and that actually works well with the stub network model because we don't want to bridge multicast either. And so using service registration protocol, which is a DNSSD document, gives us the functionality that we need without requiring multicast. It talked about using, the original document talked about using the advertising proxy to advertise whatever was registered in SRP on infrastructure. It didn't talk a whole lot about any other service discovery. It was mentioned, but not in detail. And then it talked about how to use NAT64 to connect to the cloud. The motivation there is that we feel like we can assume that, at least in the short term, a typical infrastructure network probably has IPv4 service on it. We can't really assume that it has DHCPv6 prefix delegation. I know that sounds a little backwards for, like, we really want to use IPv6 as much as possible, but that was the conclusion that we came to. And so therefore we relied on NAT64 for cloud connectivity. And as I said, we didn't put in a whole lot of detail about discoverability across non-adjacent infrastructure links, which is something that we will want to do in the second document that we work on, but isn't needed for the first. Next slide. I'm going over this in kind of a lot of details. Probably some of you guys already know most of the history of this, but this is just for those folks that maybe haven't been following this very closely. So what I changed in the current document is I removed a bunch of text. So I removed the text about DHCPv6, and I removed all the text about reachability and discoverability from non-adjacent links. Both of those require cooperation from the infrastructure. It's not clear that, the cooperation from the infrastructure for DHCPv6 is already something that you can get. So that's a little bit different than the other cooperation. The other cooperation is we actually need the infrastructure to wire the stub network resolver functionality into, or DNS functionality into the infrastructure network DNS resolver. So that's kind of hard. So that we took out of the basic document. And then the problem statement document was kind of long and detailed and talked about a whole bunch of different possible solutions as well as the problem. But there was some useful text in the document. It's not clear that we need to publish the problem statement document as a working group document, but some of the text was useful, and so I took that text out at the urging of Mark and put it in this document. So the introduction is a little more detailed and hopefully more helpful. And then I got a start on putting in state machines. So I did a state machine for the management of the on-link auto configuration prefix for the infrastructure network. And the idea here is it's not so much to prescribe how you should implement it as to give you an idea of what the problems are that you have to deal with and to propose a way of solving it. Previously, I just kind of said, this is what you need to do, here's how it ought to behave, good luck. And I got a fair amount of feedback on that was not enough detail. So I added that detail. And I think that there's probably similar detail needed for some of the other things that the stub network does, but that's not currently in the document. Next slide. So what's in the document now? We have, sorry if this is a bit of an eye chart. We have maintenance of the usable prefix. So that's the infrastructure IPv6 prefix. If there's already an IPv6 prefix on infrastructure, we don't have to do anything, but if there's not, then we need to provide one. And it has to be usable, meaning like an Android phone has to be able to get an IP address. Android phones don't support DHCP, so that means that it can't be a DHCP prefix. That is a DHCP only prefix. The A bit has to be set. There's also text that talks about the maintenance of the off-stub network routable prefix, which is a very long word for the prefix that's on the stub network, the IPv6 prefix that's used on the stub network. That prefix needs to be advertised. So there's some text in the document that talks about the fact that you have to advertise that prefix in a router advertisement. I noticed as I was writing the slides that the text doesn't actually say that you have to forward stuff to that network, but obviously that's implicit and we need to make that explicit in the document. Similarly, we have to advertise routes to the adjacent infrastructure on the stub network. That's a bit architecture dependent. For the infrastructure network, we assume that we're using RAs. For the stub network, we can't really assume that. In sort of the current use case that we're actually using this for, we don't do RA. The thread is an 802.15.4 based mesh network, and it does not do RAs. It uses a different mechanism for advertising this information. So the general assumption in the document is if you're doing a Wi-Fi stub network, then you're probably going to use RAs. But if you're not, then you're probably going to do something weird and exciting and different. So then the document talks about service advertising and discovery. This is actually, there's a bunch of things you have to do to make this work in all cases. There's two problems. One is advertising and the other is discovery. And each of those problems is handled differently depending on whether it's on the stub network or on the infrastructure network. So on the stub network for advertising, we use SRP. So we're assuming that this requires host changes, or not host changes. Since it's kind of a greenfield environment, we just assume that we can say the host uses SRP. Then for discovery on the stub network, there's two different types of hosts you might want to discover. One of them is hosts that are on the infrastructure network, and the other is hosts that are on the stub network. And actually, an additional point here is that there could be more than one stub network connected to the same infrastructure network, and we actually really want the stub network hosts to be able to discover stub network hosts on other stub networks as well. That's not currently talked about in detail in the document. I'm not even sure it's talked about at all. But that's a thing we need to be aware of. For discovering infrastructure hosts, we have a discovery proxy. That's another thing. That's an RFC that came out of DNSSD a couple of years ago. And the idea is that you have a DNS DNS server, an authoritative DNS server that's authoritative for a particular zone. And when you ask it a question, rather than consulting its authority database, it goes out and does an MDNS query to try and get the answer. So, the discovery proxy sits on the stub router and does queries on the infrastructure network to satisfy queries from stub network hosts. And And then for stub network hosts, it's relatively straightforward. It's just an authoritative zone. You do DNS queries to it. So the SRP updates an authoritative zone, and we just answer questions out of that zone. Now, for discovery on the adjacent infrastructure, first of all, we don't need to worry about adjacent infrastructure hosts discovering each other because we assume that that's already working. That's not our problem. And so we leverage that to also make it possible to discover stub network hosts. So instead of doing DNS queries to the authoritative zone that's populated by SRP, we answer questions that we see on MDNS using the contents of that zone. That's called an advertising proxy. So that's pretty straightforward. And then the other thing that's covered in the document is the maintenance of the NAT64 prefix. And again, that's going to need a state machine, and it currently doesn't have one. So there's further work to do there. So that's the current state of the document. Next slide. So we've had some discussion. One of the questions is, do we really want to do NAT64? Can't we do something else? And you know, there are a lot of reasons not to do NAT64, but the bottom line is we don't really have an alternative. You know, unless we just say that the stub network host can't reach the internet, and I don't think we're really able to say that. So, so that means that we have to provide some way for stub network hosts to download firmware updates and potentially talk to cloud services. We can't assume IPv6 connectivity. Even if the home has IPv6 connectivity, it may not support prefix delegation. But it almost certainly has IPv4 connectivity in some form, even if that's NAT64, right? So it could be that you've got an IPv6 only home, but the ISP is providing you with NAT64 so that you can reach hosts on the IPv4 internet. That's fine, that works. We have to support that as well. So in other words, we're using NAT64 in this case, but we're not providing NAT64. We're just taking advantage of existing NAT64. Now we could, of course, say, you know, if you don't have DHCP v6 prefix delegation, then tough luck, you can't talk to the internet. But I don't think we can really say that. So unfortunately, I would like to put DHCP v6 prefix delegation into this document, but this isn't a reason to do that. That's not going to solve this problem. So that's the NAT64 question. I think we concluded that NAT64 is required, but I'm not positive that everybody fully agrees with that yet. So if somebody disagrees, then you know, there's the microphone, or you can bring it up on the mailing list. Next slide. And then the other question is, do we want prefix delegation? It's a bit complicated, but you know, it's something that could be available, and it might be nice to support it, and wouldn't be that hard to add. But I don't think it's necessary to satisfy the requirements of the basic document. So the main reason that I'd be inclined to include it is just that that means that we don't have to modify the state machine in the cooperating with infrastructure document. So the state machine for managing the OSNR prefix needs to handle DHCP v6, simply. And so if we don't do it in this document, then the next document is basically going to just have to modify that state machine to include support for DHCP v6 PD. Is that a big deal? Maybe not. But that's basically the reason why I'm a little bit tempted to suggest putting it in the basic document. So I'm curious if anybody has any opinions on that.
Let's finish the.
Yeah. Okay. Okay, great. So next slide. And then, you know, remaining work, I think, you know, we don't have a state machine for NAT64. It's possible we need other state machines. Certainly my implementation has a state machine for managing the presence of the SRP server. It's not clear that we need that in this document, but maybe we do. We're relying on a document that's currently a working group document in the DNSSD working group, the advertising proxy document. That document is currently under development and in flux, so it's a little bit difficult to say exactly what we need to pull out of it and whether we need to add something to it. But that's a thing that we need to figure out as we're moving forward with this document. Another question is, we talk about the potential for a partitioned stub network and what we need to do in that case. We don't have a whole lot of text about that. The reason for that is because partitioning, I think, is a very application or you know, a very network technology specific thing. So like Thread has a way that it does partitioning. I don't think we want to be talking about Thread in this document. So therefore we can't really talk too much about how Thread does partitioning. So basically the document is just saying like, this is a thing that you're going to need to deal with. And the question is, how much do we need to say about that? So it would be good to have people read the document and see if they think they understand how to deal with partitioning based on what's currently said in the document. And then the text about reachability doesn't say precisely what to do, like it doesn't say what to put in the RAs in detail. And I kind of suspect that it needs to say more, but you know, I'm curious what the working group thinks about that too. Next slide. And then basically my goal in getting up here and talking to you guys and telling you about this awesome document that I've written is that I hope the working group will adopt it. And I hope people will read it. It would be great if somebody wanted to do an implementation. I realize that's a big ask, but that'd be cool. So, and you know, like Pascal is doing some interesting 6LoWPAN stuff that I don't really have any visibility to. So it'd be interesting. You know, I know Pascal does some application stuff. It'd be interesting if Pascal's interested in doing that, or anybody. I don't want to single you out, Pascal. Just you know, I happen to know that you're doing stuff in this space. So I think that's it. Next slide. There's no next slide.
There's no.
All right, we're done. So I think it's Pascal's
So we
turn
should
now.
open the queue,
Okay.
and while my co-chair is getting back on as a chair on the meeting. So how should I?
Just call Michael.
Oh, we know. I mean, we can
Okay,
see it on
there's
the screen.
nothing I need to
There's
do.
nothing
Okay.
you need to do.
Okay.
Yep,
No.
you're fine.
Sorry.
Michael Richardson. So in the pathological case that the ISP is forward thinking and has provided the customers with V6 only networks with a ISP provided NAT64, then if we don't have DHCP V6 PD, then we have a failure, right? We don't get internet connectivity because we can't NAT64 ourselves because there's no V4 on the local network because they're using NAT64, right?
Yeah.
Yeah. So in the forward-thinking case
Michael?
of a successful transition,
Yes.
we have a failure.
Yes.
So
yes.
I think it's worth writing DHCP V6 PD into the state machine
Okay.
exactly for that reason, even though we don't actually have any requirement that says that CPE routers are supposed to provide it on the southbound interface.
Yeah.
Right. So it seems that we need to say that. I would like to do that, to make them do it, but to write it in a document that updates whatever 7084.
Yeah. I think we should do that somewhere.
Right.
Probably not here.
But in this document in our state machine, it seems that we should do that.
Mhm.
And otherwise we have a failure when we are successful with the ubiquitous deployment of IPv6, then we have a failure.
Yeah.
Right.
This is a hugely good point and the precise reason why I wanted to bring this to the IETF and not just do it somewhere else, because I hadn't even thought of that. So thank you.
So Eric Green, as the INTEDI for this, I was really concerned when I saw NAT64 coming up because I want to get a very small document implementable, right? So I don't want to repeat on that, as you know. But you convinced me, right? So keep it there. And then Michael, you stole my words about DHCP.
Yeah, and we want to keep NAT64 as simple as possible. Like we could do a really fancy NAT64 thing. Let's not.
Tim Winters, QA Cafe. So a couple things. I definitely think we should put PD in this document. I definitely think we should, I'm going to write a draft for PD on the backside of CPEs because a lot of them have servers, all of them have servers, but they don't turn on PD. So they have these giant prefixes that they don't do much with.
Right.
So I think we probably need to give them some guidance for sure.
Great.
So I'm definitely going to put something, I guess it's V6 ops because that's where 7084 was done.
Yeah, V6 ops are, I don't think you're doing protocol extensions. So if you were, maybe.
I don't know. It's DHC or I'll talk to people.
Yeah.
It's either DHC or V6 ops.
We'd have to recharter, but I wouldn't
Mm.
object to that.
Yeah, I mean, 7084 is in a weird spot. It was always in V6 ops. I guess it can live there.
Yeah.
The only other thing I thought you should talk more about is the reachability. You asked about that.
Mhm.
I read it, and that'll be a problem for people, would be my guess.
Okay,
So I think you're going to need to put a little more detail. I'll send some notes about that.
great.
though.
That would be really helpful.
Okay.
Thank you.
Hi, Bob Hinden. So first of all, I may not be up to speed on this, so what I say may be wrong. But it seems to me for NAT64, if there's NAT6, maybe this is what Michael said. If there's NAT64 at the the ISP edge, then I don't think whatever this is defining shouldn't have to do anything. Because if it doesn't exist there, then you don't need to do anything.
Right. So there is one little wrinkle there, which is that when we wrote the thread spec, and we don't necessarily have to carry this over to this spec, but when we wrote the thread spec, we decided that we really didn't like the idea of breaking DNSSEC, and therefore that it was the responsibility of the host that's doing the lookup to do the synthesis. And so that had some follow-on implications on, like, actually the stub network router does kind of need to do a little bit of assistance, maybe not. I mean, you could just do the regular IPv4 only.ARPA query, but we might want to do RAs that, if it's a Wi-Fi network, we might want to do RAs. In the case of Thread, we actually put something in the Thread network data that says, here's your NAT64 prefix.
Well, yeah, I think the goal should be try not to have to do anything. Make this as simple as possible, because more stuff you start adding in here, then it seems to me you go down the road of why are we doing this, and just make it a real router with real routing protocols.
Well,
so
the reason we're doing this is because we need to be able to have a router that works without you having a manager.
Exactly, but the more complexity you add, then
Sure.
you start to lose that goal.
Yep. Thanks.
Lorenzo Colletti, I just wanted to say I think we should have PD in the base spec. I understand that there's a lot of stuff in this document already, but maybe a better way is to split the document in sort of routing and reachability, and then service discovery, and like have those be separate bits of the architecture, right? Because I think it's important to have some proposal for how end-to-end should work. And now, even if PD doesn't work, I will note that you could probably do ND proxying if you had if you had a native v6 prefix. Not sure it's worth it. It's very hard to get right.
Yeah, and it's
so
not very scalable.
You probably don't want to do that. But and I don't oppose having that 6.4 here. I mean, I think, if you want to talk to the internet, you need a PV4. So
yeah. Okay.
Thanks.
Stuart Cheshire from Apple. When I put myself into the queue, I had a comment, and everybody else has basically said the same thing, so I'll make this short. I think we definitely do want to talk about DHCP v6 prefix delegation. We also want to talk about the state machine, of how you discover when it becomes available and what you do, and how you discover if it goes away. And I'm coming up to say this because I had a discussion with Eric Klein last night where he had got a different impression of this work. And in his mind, he thought we were building some kind of overlay network so that you could connect a bunch of stubs to each other in a private way. And he objected to using RAs because that would pollute the caches of the hosts on the Ethernet and the Wi-Fi, and they might know about the stub network. And then we had a conversation. That's the point. We want hosts to be able to communicate. And the other thing is that we're not trying to, our goal is not to build a little private overlay that can't talk to anything else.
Right.
Our ideal situation is, I mean, in this case, it's Thread that we're talking about, but so I'll use that example. It'd be nice if every Thread node had a global unicast IPv6 address that it can freely use to communicate with any host using any protocol that runs over IPv6. The stuff about making up ULAs and advertising them in RAs is just a fallback for when the full connectivity is not present.
Right.
So we definitely want to focus on the ideal case, and then talk about how do we get something that's not quite as good when we don't have everything we want.
Yeah, it's a good point.
I agree.
Okay, I think we've got a pretty clear consensus that we should put DHCP in the document.
Yeah,
I mean, I'll leave it to you to call the consensus, but that's my personal impression as an author.
I agree.
Okay,
Other questions?
it looks like Julius is in the line.
Julius is on.
Working group adoption will wait
Yeah.
until after the others presentation. So.
Okay.
So if I can say a few words. Yeah.
Please go.
So I'm not quite as sure as you make it that NAT64 is unavoidable. There are other possibilities. So Michael answered quite convincingly why there are good reasons to do NAT64, but I would still like to mention that there are other possibilities. My personal favorite would be to have IPv4 and IPv6 tunnels. So Michael answered quite convincingly that this requires a full IPv4 stack on the stub node, which might be a problem, but still I'd like us to consider it. And one thing I would also like us to consider is whether we really need full IPv4 connectivity. So perhaps I'm going to get yelled at right now, but if all we need is HTTP access, wouldn't it be enough to have a SOX5 proxy on the stub router?
That sounds a lot more complicated than just having a router.
I'm not sure. I'm
right. I mean,
just saying that
NAT64 is not that complicated. I mean, yeah, you're rewriting some headers, but it's stateless. You know, like having an HTTP SOX proxy, that's pretty heavyweight.
okay, but the point I'm trying to make here, so that was mentioned on the list. I think I'm not alone in wanting the NAT64 stuff to be in a separate spec, so it can be discussed separately of the very good, very interesting and very good work that's in the rest of this document. And I'm wondering whether you would consider splitting it out into a different document so that this can more easily be discussed separately.
I mean, I think, you know, my experience with you know, it's a very common thing for people to say, let's split the document up. And my experience with that is that quite frequently what winds up happening is we split the document up, we write several different documents, we wind up with a lot of text that's fairly confusing, and ultimately the working group says, why don't we just like take all of these documents, like why do we have so many separate documents? Like 2 years later when everybody's forgotten why we have so many separate documents, why don't we put these documents back together and, you know, just make one document? It's a lot simpler. So I think we need to have an actual reason to do that and not just that we think that NAT64 is less yummy than you know, end to end, because, you know, I agree that it's less yummy, but, you know.
Okay, fair enough. Thank you.
Yeah. Esco.
Yeah, Esco Dijk. Yeah, just to react on the previous point, was mentioning maybe to have IPv4 also on the stub network nodes, but yeah, of course we have also 6LoWPAN type networks that we want to connect as stub networks. So Thread is one example of those.
Yep.
So it's not really feasible, I would say, to change those into supporting IPv4, which they don't. So that seems not a good path, I think. But my question was actually on the problem statement. Ted also mentioned that. So I also see sometimes in a working group a separate problem statement document, and we don't seem to have one. Is there some sort of history of how it how this evolved, or that we have the problem stated in your document, or?
So I mean, that's a thing that you know, there's always a big debate about whether we need a problem statement document
Yeah.
and whether the working group needs to publish it is actually the important part. So we did actually write a problem statement document. It expired on Monday. And so the question is, do we actually need the problem statement document, or is the text that I pulled out of the problem statement document and put in this document sufficient? I don't know the answer to that. If the working group wants to do a problem statement document, we're certainly well poised to do one. So.
Mark, I'm responsible for for that. The problem statement was kind of all over the place, not necessarily in a bad way. It's just that it was
comprehensive.
Comprehensive, thank you, for all the possible cases, right? And then to have, and we discussed to have two different deliverables, clearly, as the simple case and the complex case, for lack of better terms. So it seems to be more appropriate to have a short problem statement for the simple case in the document that describe the solution of the simple case. That's the whole.
Okay, that's
instead
the
of having
history. Okay.
all of
So,
it.
so there is actually a problem statement document apart from the charter document. Okay.
Yeah.
Okay, thanks.
Yeah, Lorenzo Colletti, I think you kind of mostly need a problem statement when people don't agree that there's a problem, or they don't agree what the problem is. I think this is pretty clear. You've got some other tech and it wants to like plug into something that's already there and talk to the internet. I think that's pretty clear and useful problem to solve. Oh, and by the way, I mean, I mentioned this to John in some other conversation. This is the first thing I've seen that might actually work. So congratulations. I mean, it looks comprehensive. It seems to have dotted all the I's, crossed all the T's, considered the corner cases. I'm very hopeful that this will turn into something really good. So just wanted to say around the, partially in response to Julius, but I think it's important to have like the connectivity bits all be in one doc, and to provide a comprehensive solution, which is kind of, let's say, all mandatory, in the sense that obviously implementations are going to pick and choose the stuff that they build, even if it says must. But I think it's important that then the onus is on them to explain how their implementation works and interoperates, right? If someone doesn't want to implement PD because they're like, this is never going to happen in the real world, then it's on them to basically make the solution work in other cases, right? I think it's important to have one sort of state machine that covers all those cases, and only one supported solution where all of these things are part of the protocol. And in terms of the size of the document, yeah, I mean, I think if we really do want to split up, I would very much advise against splitting up, things that like could be added on later. It's going to result in bad interoperability and like hard to debug. Instead, if we want to split something up, yeah, put the service discovery bits somewhere else and put the connectivity bits all in one doc, and they will contain NAT64 PD and everything, and the arrays and everything, right? So, but I don't think you necessarily have to split it up. That's sort of, just something for the working group to decide.
Okay.
Looks like we have no more questions.
All right. I will defer to Pascal then.
Yep.
So this is Pascal from Cisco, and I'm talking about a document which is being proposed at 6LOW, so it's not a document for this working group, but what is being discussed in this document could be a tool in the toolbox that you might decide to use in building your solution. Certainly it's not a comprehensive solution like the document that you're doing, but it's one element that could be considered in the solution. So, next slide, please, Mark. There is a long history behind what I'm going to present to you. 15 years ago, pretty much, we looked at the concept of IoT and tried to figure how we could run internet protocols on battery devices. And that happened to be very, very challenging because the way we designed protocols at the time was not considerate for energy. And so we had to look and over the time learn a good number of lessons on how effectively we could turn those protocols into something that could reduce the energy consumption. And probably the first thing that we found was that the use of broadcast was a killer. So we had to separate the broadcast domain, the concept of links, at the layer 2 with what we use for subnetting and IP links at layer 3. And doing that, we found that we had not only to use routing pretty much everywhere in what we're doing, but also that we could not use neighbor discovery as it was as a reliable mechanism to learn which IP addresses were present in the network, so we could inject them in the routing. if we don't have a deterministic knowledge of which IP is where, then there is no way to inject that either in an IoT network for routing or in EVPN or whatever. So we worked on that. We looked at neighbor discovery, and we considered how it could be done in such a way that effectively we could know deterministically which addresses were. We could not choose SLAC because it relies on broadcast, but we still needed address auto configuration. So we defined something we could call stateful address auto configuration, started with RFC 6775, learned a few lessons, and ended up with RFC 8505. So RFC 8505 is effectively a contract between a host and a router, which will guarantee both parties that they agree that this address is usable for the host, will not be stolen by somebody else. And from the network perspective, that it's not exceeding the capacities of the network. And then both ends basically provide some information. It's kind of a contract. After that, we built a number of other documents like RFC 8929, which is how you do ND proxy. Based on that, as soon as you know deterministically which address is on the network, you can do ND proxy for it. 8505 is not limited to ND proxy. It's an abstract contract between a host and a router. In that contract, the host can say, please, Mr. Router, whatever you're doing for routing, please do it for me. So that can be ND proxy. In the case of RFC 9010, it's going to be a repo. It can be a Rift. I mean, there is a draft for EVPN as well. As soon as you have a deterministic knowledge of the IP address, now the routing can manipulate it. The other thing that was not possible with ND was securing this contract. We wanted to make sure that if somebody else comes in somewhere and says, hey, I'm him, there was no way he would get the ownership of the address, no way to get the address stolen. So we have RFC 8928, which is basically associating something derived from a private key, basically. So some crypto mechanism that basically does not need a PKI to start with. It is just a pair of keys that the device will autoconf at the same time it autoconfs the address. But then the infrastructure will associate the two. And another thing that I have to say about those things is there is an abstract registrar, which is not DNSSD because we designed without it, but it is an abstract registrar which knows exactly which addresses are present on this network and which cryptographic token is associated with those addresses. The way this abstract registrar is implemented depends on the use case. In the case of EVPN, it is BGP itself, right? The whole information is replicated in each PE. Basically, they know where the VXLAN tunnels are. They know which addresses are at the end of the tunnels. They also know the cryptographic tokens associated with those addresses. In the case of 8929, it's going to be there is a local knowledge by the proxy ND of the addresses that it proxies for. And the overall 6LBR, this overall database is the distribution of all those proxy information across the access point doing proxy, for instance. If you're doing repo, we expect effectively some form of central registrar to maintain that thing, something like Lisp, for instance. So the registrar itself is very abstract. There isn't, if you guys would decide it's DNSSD, it could be DNSSD. Just to say, okay, we are not imposing any way. It's an abstract thing. So the family keeps being extended. And the reason why is those protocols that we define, 6LoWPAN and D, repo, etc., are effectively deployed in the context of smart grid. We managed to build subnets with thousands of nodes, and they are effectively deployed and running today. And the alliance, the equivalence of the Wi-Fi alliance that does that is called WiSUN. And WiSUN decided that they needed multicast. So for 8505, we don't need MLD. We don't do any form of solicited node multicast or anything like that. We are all based on stateful knowledge of every address in the network. So there is no need to pull from solicited node multicast because there is no lookup in the end. There is no discovery. Now, So still, they discovered they needed MLD because they wanted some degree of multicast. And for the same reason they didn't want broadcast for unicast ND, basically. They could not afford the broadcasts which are coming with MLD either. So what we decided to do with this multicast registration thing is to use the exact same mechanism to proactively tell the network, hey, I'm subscribing to this address, as opposed to having the network pool. As you design for low power, you need to realize that those low power devices are sleeping a lot. You have to let the low power devices control when they wake. And it's on their demand that something can happen when those devices wake up. So for the same reason we register unicast when the nodes wake up, they will register multicast as well. And we built this multicast registration. Since we have this global knowledge of every address, then the concept of broadcasting for lookup doesn't make any sense either. So we have this unicast lookup, which is another abstraction on how you go and consult the 6LBR to basically tell you which addresses exist and if you have a broadcast domain, how you can reach them. Now, there is a new member in this family. We introduced it 2 IETFs ago in 113. And the concept here is when we build those very wide ripple networks, we never want them to be transit network. We never thought ripple as a transit network thing. And it could become such. If you have a need like that, there are all the mechanisms for it. But it was never thought to be a transit network because it's an IoT, typically an IoT network. Now it's a layer 3 protocol. It's not limited to IoT applications, but it's still thought as an IoT protocol. So we don't think of it as a transit. Doesn't mean we don't have such a thing as a not so stubby area. That could exist. RFC 6550 was designed with the concept of external routes in mind. So there is a need for connecting non-so stubby areas to ripple. It was recognized from the start. Next slide, please. So the question is, would it make sense to do the exact same thing as we did for anycast, multicast, and unicast addresses, but for prefixes as well, so as we can advertise in a protocol-independent fashion the direct reachability of one prefix, as opposed to say, hey, I have this address. If you need to contact this address, come to me. I'm directly connected to it. It's my address. Could we now say the same thing for a slash something? First usage, obviously, is I have a /64. I'm a host with /64 to the host. Could I just tell my Ripple network, hey, I have this /64, inject that for me, please? And then it could also be redistribution. When you do routing protocols, one thing you're used to is, hey, you have a prefix behind you, which is handled by a other protocol. You don't really know what that protocol is, but you know that you can reach that prefix. You're connected to it. You don't need routing with cost and multi-hop. You're directly connected to it. So guys, if you want to reach that prefix, pass the packets to me. That's pretty much what the R flag does in RFC 8505. So this is a very, very simple graph, which basically says, hey, now it's not just an address, it can be a slash something. He's still connected to me, I own him. I can be your next stop. Next slide, please. So this is the case of Ripple. So we have this RFC 9010, which basically says, you've got this guy, Mr. L, doesn't speak Ripple. He doesn't care that the network is Ripple. Could be VPN, same interface, completely abstract. All this says is, hey, I have this address. And there is the Airbit. If you're doing any form of routing, do it for me, please. Because I won't be doing it myself. So if this node L participates to Ripple, it will not set the Airbit. But if the node doesn't participate to Ripple and hopes that the router will render the service, then it will set the Airbit. Route for me, please. And the result is what you see here when the infrastructure is non-storing is basically the router C, which is the router to which this device is directly connected, will basically inject the route into Ripple and the packets will flow back. The 8505 is acknowledged, so the host is certain when the acknowledgement comes back that this address will be processed and inserted into the routing, so it is certain that it will get the traffic back. Next slide, please. So, well, next slide. What we don't have today is the equivalent of 9010, where instead of saying, hey, I have this address, you would like to say, hey, I have this prefix. Okay, so again, what we are doing is in this interface is completely agnostic to whatever routing is happening up there. It's just a matter of saying through a simple ND message, I'm this guy, I have this /64, or I'm directly connected to that network. If you have packets for that network, you can trust me, pass it to me. There won't be a loop because I'm connected to it. It's a stub. Okay. Next slide, please. So since I followed your work and I saw that this group was being formed, I thought, hey, let us at least share to see if there are things we could do in common, or if you would be interested in extending or using what we're doing, since we are beginning this work. It's completely elastic, and if you would need it and could use it in your solution, and you need some changes and some adaptation, it's completely easy at this state of time. So I basically wrote 2 sections in this document to show 2 use cases that seem to map what you're doing. And the first use case is you get a single link here, which is a shared, so we have what we call a shared link, basically a very ancient way of doing things, where you have more than one prefix on this shared link. And you basically have this 6LR2, which is a stub router, which knows about prefix 2. It could be a phone connected to the home network. And P1 in yellow is really the guy connecting to the internet. And all you want to do is 6LR2 on the right to tell P1, hey, I have this prefix. And so what can happen on a network like this is once the P1 knows about P2, basically it can install a route to the prefix, to P2's prefix and send the traffic. And if P2 finds the traffic on the same link, it can always use a redirect to optimize the path if that's desired. Next slide, please. So another case, but it really works similarly, is if 6LR2 is actually has 2 interfaces, one thread and one Ethernet or whatever else. And in this case, you would basically, in the same way, register the packet, and the packets would be routed, but there would never be a redirect. Another thing that could happen is if you have an IP network up there, for instance, this is an industrial plant, you could also decide if the R bit is set. Remember, this is controlled by the R bit. If the R bit is set and there is OSPF on the right, you could always make it so that the prefix in orange or the prefix in whatever color you see it here. I think this is yellow for you, green? I'm not too sure. Well, anyway, you could decide that they are injected or not. This is controlled by the protocol. There is this R bit which says, route for me, please. Right. So all this is in the specification. Next slide, please. And it's a very, very stupid extension to 8505. Just the capability to expose a prefix length, basically. Now, there is also the case, and this is more for cloud application. Remember, I told you you can redistribute 8505 in anything you like, can be EVPN. There is a big draft which explains how that works for EVPN. When in a case like this, knowing that Kubernetes mostly works for v4, v6 is now available, but it mostly works for v4, and we do all those overlays and games. We could also do a flat v6. And if we do a flat v6, basically we provide this usual 96/96 for a given private network, and we basically replace IP in IP by IPv4 in IPv6 address. So we replace a tunnel by an address inside an address, and we get pretty much the same result. So the way 8505 works today is what we call the arrow option, which is placed in the NS. So the host sends an NS message to the router, say, hey, I'd like to use this address. I have autoconfed it. It comes from the sky. You don't have to know how I built it, but I would like to be using it. And the router says, fine, it's not a duplicate. You can have it. If we do it for prefix, do we still want to use NS? Would we like to use RS to carry the arrow? Should we still call it arrow, since arrow means address registration? Should it be SRO, stub, stub prefix, or whatever stub registration option? And there are things that we need to discuss just about naming and which message should carry this thing. And this message that you see on the right is the abstract way of talking to the NSSD. It's how you go and register and say, hey, I have this prefix. Next slide, please. And then again, the prefix can be obtained by the HTTP PD or whatever else. And that's something we need to discuss. What becomes of that? That's the nasty question. Because remember, for address, we expect auto-configuration. So we expect to do autoconf as usual, and then you go to this registrar through your router. The router will consult the registrar, like your BGP table, and look whether this address is already in use or not. And if it's already in use, 8505 comes back with a status, say, hey, duplicate, you cannot have it. Could we autoconf prefix? That's part of the name of your working group. Would you really like to do autoconf? Like not even PD, but really autoconf. So you basically expose a /48 in your arrays, and the guy picks just an arbitrary 2 bytes and registers that. And since we can do it for addresses, we could also say, hey, you can have it, nobody registered it, or you cannot have it for that reason. And you could even have some policies in that abstract registrar which talks about subnetting and subnetting and subnetting. I mean, everything now is open. If it's not already done, if the policy allows, yes, have it. Because we always think in terms, and that was a discussion in terms of the HCP PD. Does it really have to be a PD? Can't we autoconf? So that's something that the draft does not really discuss, but is completely behind it. Since we have a model for autoconfing addresses, why would we not autoconf prefixes as well? Next slide. So last but not least, compared to ND, we have zero trust built in the protocol. The host, when it configures an address or a set of addresses, it can do a single key pair for multiple addresses. It will also autoconf a key pair. I'm not talking about a PKI. I'm just talking about a single key pair. What happens is, since the network keeps track of all the addresses which are registered, it can also keep track of a cryptographic token that was associated to the address the first time it was created. So basically, the host, when it autoconfs an address and registers it for the first time, in the other option, there is this route ownership verifier field, this rover field, which can contain a crypto ID. The crypto ID is derived from public key and stuff. And there is this usual challenge that is done by the router. Each time the host wants, a host that the router doesn't know already, wants to do something about an address, it will be challenged for the ownership of that address. Whether it is for injecting in the routing, whether it is for mobility, the node was there, it's here, for the router, it just shows up. Is he really the owner? There will be this challenge. And this challenge is basically a pair of nonce and validating that the host has the private key associated with that crypto token. So compared to CGA, this is immensely simple, because we are not constrained to having the token fit into the interface ID. And the reason why we are not constrained to that, it's because there is the registrar where we can place this rover, which can be any size.
Sure.
Okay,
Yeah,
so compared to CGA, which is really, really complicated, this is just a simple cryptographic operation where the host will prove that it has the token that is associated in the infra with this address. So you can form any address, first come, first serve, you own this address, it's associated with this token, now it cannot be stolen. And you can do Savvy and you can do all those games. I think I have a next slide, but
I don't know what happened.
magic.
Yeah.
So we're pretty much at the very end anyway.
Yeah.
I don't think they have much time, right?
Yeah.
The network is pretty flaky here today.
So where we are is, this is a very new work. It just, for now, it just describes what we already have with 8505, but for prefixes, can be used to advertise not so stubby areas in repo or in any protocol.
Yeah, I know, but I don't have to.
Whether we do autoconf is to be discussed. Whether we call things arrays and arrays is to be discussed. So we have a lot of slack, if I can say, in this protocol. And so welcome for comments. And if you guys would like to use it and need some things in there, then it's completely open. Can you next slide, next slide?
Oh, okay. Wow. Thanks.
Yeah, so I have a big list of things we could be doing: policies, ACLs, load balancing. When you register to multiple, mostly in the case of EVPN, if you register to multiple leaves, you could influence the way load balancing is done back to you. Just the way we have router preference, we could also have equal cost multipath balancing type of signaling. I mean, all sorts of stuff we could be doing.
Good.
So I think there are a lot of really useful ideas in here. I would say we shouldn't invent a new protocol that does the exact same thing as an old protocol. So I'm not really that interested in autocont for prefixes, because DHCP, basically you've got a stateful server either way. So why not just use DHCP because it's already defined? But there are a couple things here that I think are particularly interesting. I think, you know, this is not really a SNAC thing per se, so I don't know that this is necessarily the right place to talk about it, but since we're talking about it, being able to de-broadcastify ND on Wi-Fi networks is a very attractive thing. Our experience with Wi-Fi networks at this point is that multicast works just fine as long as the network is in a good state. But when the network stats get a little ugly, then multicast stops working so well. You wind up having to retransmit a lot. It might take a minute to get an answer instead of, 100 milliseconds. That's really bad. Yeah. So so doing things to avoid turning on the multicast functionality in Wi-Fi is probably something worth talking about. Maybe not here, but I'd like to see that happen somewhere. And I think some of the stuff you talked about here is highly applicable to that. I mean, I think some of it's, some of it's intended for that, but so that's good. The other thing you talked about that I think is interesting and potentially useful, although I won't say that I don't care about Ripple, because I think we do care about Ripple in some cases, but just addressing Ripple is not general enough. The ability
abstract to Ripple, right? I hope I mentioned that.
No, yeah, no, I got that.
Abstract.
But yeah, so but when I looked at RFC 9010, it's like about Ripple. So so having something that allows us to inject routes is definitely something we'll want for the follow-on document. We need to be able to do that somehow. I mean, one of the ways that we could do that is just by having assuming that the DHCP PD will result in the route being injected into the routing plane, but
which means it would do that probably.
Yeah, right. But the point is, we in this working group could sort of hand wave about it, because that's how PD generally works nowadays. I mean, and there isn't a spec that says how it works. On the other hand, it would be kind of nice if there were a spec that says how it works. So I think that would be worth doing. So generally speaking, I think there's a lot of good stuff in here. I think we need to talk about it a lot more before we actually kind of tease out the exact thing that we'd want to try and do. And also, it's not clear to me that this is the place to do it. But
this is a 6LO document,
yeah,
right?
yeah,
it happens regardless, but if you have
so
interest.
It's not clear that 6LO is the place to do it either, though. That's the problem.
Well, that's why it was proposed. It's not adopted.
No. So the 6LO specific stuff that you're working on, I think, does belong in 6LO, but there's some interesting stuff in here that I think we need for more use cases than just 6LoWPAN. And so that's why I'm saying maybe that's not the place to do it. But because I mean, to some extent, venue shopping is just kind of a silly exercise, but it would be good to make sure that we do it in a place where there are more people than just the 6LoWPAN people participating in the conversation.
We've tried to bring that idea to Sixman a number of times, and the person behind you knows that very well because he was the one opposing it.
Okay, so that's basically all I had to say. I mean, thank you for this presentation. I really appreciate it, and I hope we can get some value out of it.
Hey, Lorenzo Calidi, I'm flattered that you think I have an influence to change standards and destroy standards and create standards. Thank you. Seriously. So I had a couple of thoughts on this regarding SNAC specifically. One general thing I just wanted to say before that is that if you want to do ARO for energy saving purposes, that's a sort of like solid motivation, right? But the trade-off there is that if the nodes are sleepy, that kind of means you can't change anything on the network because you can't talk to them. So on a home network, which might potentially change dynamically, for example, a lot of European ISPs do flash renumbering once a day, sometimes even more often. You kind of need the ability to talk to those nodes anyway to update them. Yes, they can do ARO, but if their prefix changed, their address is no longer valid, right? So that's one thing. Like the trade-off is like in that case, the energy trade-off is not as clear.
I can answer that before you ask the next question.
Yeah.
So basically, the whole idea of IoT devices is that they can sleep. Obviously, when they sleep, they don't do anything, so they don't need to know that the prefix has changed. They only need to know when they wake up. So saving energy is, for the first thing, going away from multicast and broadcast. You need to completely stop that game. Second thing you have to learn when you do low energy is allowing for sleep. Those devices can sleep 1% of the time, 10% of the time, or even as much as cats. Now, as long as you sleep, yeah, that's a lot. As long as you sleep, you don't need to know there was this flash renumbering. What you want to see happen is when the node wakes up, then it gets this array which will tell you, hey, the PIO has changed, and now it will autoconf on your address and register that. But during the sleep period, it doesn't.
But then you
really
don't need
matter.
to use ARO. You can just like drop all packets, and when you wake up, you refresh.
Well, whatever. I mean,
Yeah.
yes. So it's a good point that things may have changed during the sleep period, and that's yes, that's a good point, and we need to
So I
cover.
mean, it's very good for a managed network where you know the prefix doesn't change and you have loads of nodes. But I think I guess that's sort of my broader point. For a home network, I think the trade-offs are a bit different. The devices may or may not have more power. I think the sleepy devices in this model are probably going to be like more in the 802.15.4 cloud, right? So they are sort of like behind the BR. And in terms of like
multicast in general on even Wi-Fi is very harmful, to the point that some devices don't listen to all of them because there are too many. So if we reduce dramatically the amount of multicast, maybe the devices will listen to what's left, making them a lot more useful.
No, they won't, because the reason they don't is that it's expensive for the hardware even to listen for the beacon.
Yeah.
So it's actually like a more complicated. But anyway, so one thing I wanted to say is in this specifically for SNAC, doesn't seem that useful, because if you do, if you try to inject a prefix into the mesh via, PR or whatever it is called, that's only going to go to the things on the network that speak the protocol, and in particular, like legacy hosts won't know this. And so what happens is, let's say that you get a prefix from the gateway. And first of all, that's going to plumb a route to you anyway. So the traffic will traffic from a legacy host will go up and come hairpin down. You're better off sending an RA on the network that with an RIO, so that the traffic from legacy hosts reaches you directly instead of hairpinning.
Oh, it can be done. Yeah, certainly.
Yeah.
If you
So at that point, if you got the prefix via PD, which is what Ted says, well, we already have it, then you might as well, instead of like doing injection, you might as well just send the RA on the shared segment where it says like, hey, you can reach me here with an RIO.
What that's the first drawing, right? The one where we share the network. You may or may not want to do that. It just depends if you want everyone to know about this prefix, or if it's a prefix that has a special purpose for which. I mean, it's a choice, administrative choice to do it or not. But yes, it's completely possible.
No, I think like the use case for SNAC is that you have this stub network that anyone on the infra network can reach. And so in that case here, I
don't think it has to be globally reachable by anyone. For instance, if you have a power grid and you want that stub for the power related messages to go out the power lines actually, but for anything else to go out, we have use cases like that in IoT. So you don't want everybody to know that prefix, only your washing machines and stuff. They're still connected to the Wi-Fi. They build on that prefix. If they do power-related stuff, they go out one way. If they do something else, they go out the other way. I mean, we want to have all the power to play with things. But yes, I mean, ARA is useful.
Michael Richardson. My thoughts about this work, and I've followed it through 6man and 6low and stuff like this, is that I think that it addresses the edge SNAC case that I really don't remember if it went in the charter or not, which is the vaguely sort of industrial uses for stub networks, and I don't think that really is in our charter, or really shouldn't be emphasized if it's there. There was a presentation, I'm going to say 2 IETFs ago, from in the IoT Ops Working Group about trends in industrial networks, right? And so, he presented these industrial networks as if it was a virtue, the fact that they had layers and layers of firewalls. And that's not really how.
That's the Purdue model, ISA 99. Yeah, ISA 99 Purdue.
Well, it's presented as a virtue, but it's not a virtue, and we know that it's not a virtue. We know what happened. It was permissionless extensions of the network through NAT44, and each guy came along with a subsystem of 5 or 6 hosts, discovered he had nothing to plug into, and then they brought a router, and that router did NAT44, and they plugged that one in, okay, and then of course. There's just extend this. So the fact that that the diagram showed 6 layers of firewalls down, but really they were just NAT44 hosts, was not is presented as a security feature, but it's really just justifying bad architecture through security, right? And the new proposal was a flat network with a bunch of VLANs and routers that actually could do things, and a way to distribute the ACLs correctly so that they had connectivity. Go back to the IoT. It's a very nice presentation and a very nice concept, right? But the key thing here that I took back is that it was very hard for any new vendor to enter an industrial network because of all of the other stuff. Nobody wants to reconfigure their network for the new guy, because if anything goes wrong, it's the new guy's fault, and they're in trouble for having cooperated with the new vendor, right?
Well, when you install a production line, you install it for 20+ years, and you don't want to touch it at all for 20 years.
Yes, exactly, right. So this is exactly what's happening. So what I'm saying is that the SNAC stub network actually has the nice feature that it actually does let people deploy permissionlessly into that kind of network, okay? And so the interesting thing for me for your work, and I'm sorry if that was a little bit like tenuous, and I could write it down. The interesting thing for this concept is that when that vendor shows up with the second subsystem, because it's another part of the plant, got a good deal, it was working well, the chemical mixer for the paint factory, right, thing, and now they want to install it 3 more times, okay? Mm-hmm. Well, now they say, whoa, hang on. We don't need a whole new subnet. We can now do EROs and this other stuff, and we can actually now build the proxied ND kind of concept across the whole thing. And I think that's very, very useful. But it requires them to think about this in advance. And I think the thing unfortunately, about this work is that it's 10 years too late to go into Thread or something else. And so we really need to do this usefully, we really needed to have put it in to all the other specs that we're doing something like, specifically Thread. And so I don't see Thread changing to be able to accommodate this. And that's why I'm like, well, I really want to do it, but I don't think that it's useful until we actually have networks that have some reason to do it. And I don't think Thread's going to adopt it tomorrow, and I don't think Matter is going to adopt it.
I don't think that Thread as an indication of version in the frames.
Okay, sure. I'm not saying they couldn't do it. I'm just saying that it's not in the spec today, and this is unfortunate, and it's an unfortunate problem of we don't always get people to, especially when people spin off and go elsewhere and do their work elsewhere, we don't always manage to review and say, well, but you could have just done it this way. It would have been simpler, right? And that's the problem, as an IETF we have. But as a seller of technology, but not necessarily a deployer of it. So thanks.
Ted Lemon, just two things. One, the use case for injecting routes is actually when you're trying to work with a cooperating infrastructure and you want to be able to have the stub network hosts be reachable from non-adjacent infrastructure links. So it's not really about access control. It's about situations where you can't get an RA to the thing that needs to connect to you because it's on a different link.
Yeah.
So
Everything is, in our perspective, every device to device is a different IP link. So everything is on a different link. So
right.
you're correct. I mean,
yeah. So, and the other thing is, I mean, I wouldn't lose hope that there isn't an application for any of the stuff that you've done in Thread, because there were some things in there that I thought, oh, we should talk about that in Thread and see whether we can do it. I'm not saying that it's going to get adopted. I'm just saying I think it's worth talking about. So.
Okay. So that is all we have.
Yeah. You want to start something, or you want me to do it? Okay. Okay. Next topic of the agenda is discussion where we're going and next steps. Am I right, Pascal, saying that our understanding, as you said, is that what you're describing, the prefix registration, is actually a possible tool to be considered for SNAC, but it's not, a complete solution, right? It's just a, okay. So I guess the question to the group is, does the working group think we should be adopting Ted's draft as working group document for the first deliverable? I think that's kind of where we are. Anyone wants to chime in and say yes, no, maybe? Do you agree, not agree, before we can kind of or something? Oh, the AD is coming.
Eric Vink, I would prefer to have a document that says explicitly, even in one line, DHCP PD support to be defined, so that we can adopt a document that includes DHCP PD clearly, right? It just takes us a minor step for you. You can do it today, and then we can adopt this. And as an individual guy, I will support it.
So you're saying, Eric, that if we ask the author to add one line, that draft then would be possibly be able to be adopted by the working group.
Yeah.
But without that line, we cannot decide this year.
No, we can't. We don't decide here anyway, right? As you know.
No,
but,
right.
But
the feeling.
my point is, if we do a call for adoption later today and for 2 weeks or whatever, right? This is up to you, chairs. We will adopt a document without the support of the DHCP PD.
Yeah,
right?
okay.
And we know there are discussions to be held.
Sure.
So I want to get one line, support to be defined, or will be there, or whatever, right? And then we can adopt this.
Okay, so, Lorenzo?
Lorenzo, do we have to do that? Like, there seemed to be like pretty solid agreement within this room that like we want to make PD parts of this spec. I think we can just say that in the email. It's like, the chairs, we're calling for adoption by, we recognize that during the discussions, there was strong support for including PD as part of the base spec. Let's assume that we can do that while the document is being worked on.
Yeah, let's call me a process freak, but there's one line that can do it. And let's be clean.
Actually, one thing I want to say is like, let's not write something that could suggest that PD is going to come in a different document. I would strongly oppose that outcome. But if we say, yeah, this document will be updated to state that DHCP PD is part of it, that's fine. Yeah.
Hi, I'm Bob Hinden. I was just going to say that adoption usually means that the working group wants to work on it. It doesn't mean there's any agreement or final agreement on what's in the document. that happens later and that gets sorted out when you do a working group last call. So I don't see why we need to add another step here.
Okay, so let's rephrase the question that if the document contains, DHCP PD, does the room feel, and room including people virtual, does the room feel that it would be a good document for a working group document? Or let's do the inverse. Do you, anyone think that this document would not be a good working group document for the first deliverable?
Do you want to run the poll?
Yeah, I don't know how to do this. Yeah, maybe. Okay. Oh, there's a poll tool. Okay. Yeah. If no, please add if it includes DHCP v6 PD. Yeah. Okay. So that's new for me. So it looks like we have a poll ongoing. Okay. Please answer. Well, I guess we need kind of a timeout or something, right? No? Looks like pretty good consensus. As Eric was saying, whatever we discuss here, we'll be doing this on the mailing list, and obviously we'll wait another rev of the document, which contains at least one liner to formally call the adoption. But this gives us a good feel for the working group chairs. Okay, I guess we can close that. That's cool. Meet Echo is fantastic. Stuart, you have a question, a comment?
Yeah, just I'm Stuart Cheshire. Remember what we're discussing right now, and those I've rarely seen such a clear consensus. What we're discussing is whether the working group is going to work on this document. Once the working group adopts the document, it's up to the working group to determine what goes into that document, right? We're not saying the document is finished and ready for last call. We're saying this is an interesting area to work on.
Yep.
I will just add that it's now officially a moot point because I just submitted a document that mentions DHCP v6.
Okay, so to do for the working group chairs to call for adoption of that new rev in the mailing list in the coming days. I think we're mostly done. There was so we do have another deliverable, and so I guess we could already call for people if there are any editor author to start working on the second deliverable while we are, working on the first one. Sorry?
What is
the complex case.
So just to clarify, the second deliverable is the case where we want to have additional functionality that is enabled by integrating with the infrastructure network. And what that would mean is essentially the ability to do discovery of hosts on the stub network from non-adjacent infrastructure links, and the ability to reach hosts on the infrastructure network from non-adjacent infrastructure links. Since we just added DHCP v6, we've sort of solved that problem, the second problem, but we haven't solved the first. So that's the big difference, I think, in the document. So the new document would basically just talk about, you know, how we would integrate this, the DNSSD stuff into infrastructure, essentially.
Done? Are we done?
Yes, about the use cases that you guys want to cover. I had a discussion this morning, I think it was with Adnan, or I don't remember with whom, but the use cases was something like this. I've got my phone, and my phone gets a /64 from my service provider. And now I'd like to connect my phone into my home so that if my home gateway works and they can get through the internet, the devices which are tethered through Wi-Fi or through USB or whatever to my phone, kind of get relayed to my home gateway. But on the other hand, if my home gateway dies, then I would advertise the /64 to the home. And then my home could still be served by my phone. You see the kind of use case? Was it clear, not clear? So take the phone, connect it.
The phone is the stub router.
The phone is the stub router, but the prefix is not provided by the DHCP PD, and you have to act as a relay for the Wi-Fi, by the way. But I mean, I'm just wondering if that could be, because at home, I would have used it recently if I had it, because I had this cut, and they cut my fiber, literally on the road, right? Road work, cut fiber. And my whole home was isolated. But I had my phone, and I could effectively tether a few things on my phone. But what I really would have liked to see is my phone takes over my home when my home is not there. But on the other hand, whatever I tether to my phone would be routed through my home gateway when my phone is at home.
So you got a mobile provider providing /56 to your phone.
So it's not the DHCP-PD, right? The bottom line, it's not the DHCP-PD. I get the prefix.
Yeah, 64, but not 56. Oh,
well, 64 typically for me. But,
yeah.
But my own goal would be to not use my broadband for when I cannot use it, but at the same time, when my home gateway is dead, hey, use broadband for more stuff. You see? And the bottom line being it's not the DHCP in that case. That's why I came to the mic.
So, Ted Lemon, what Pascal just described is a use case that sort of fell into the HomeNet charter, but doesn't entirely fall into our charter. And there's a reason why we constrained our charter the way we did. It's because we want to get something done that actually works. And that's not to criticize what Pascal is proposing, because I think what Pascal is proposing is also useful. But we probably ought to get the work done that we're chartered for first, and then we can see if we want to stretch it.
I feel there's someone here is going to the mic soon.
Yeah, Lorenzo Cludi, I think that's out of scope, but also, I mean, this is not, it doesn't need any protocols to do this, right? Like all you need is an option on your phone that says become a router for the Wi-Fi network, and that's it, right? I mean, I don't think the mobile devices on the market today have this option. That's partly because mobile data is so expensive, and something that you really, really, really want the user to tell you explicitly that they want. But like, it's not hard to build such an option. And all the bits that you need are there today. You just like send an RA and then you're done. So I think, yeah, I don't think that's, maybe should be here.
Michael Richardson here. So I think it largely works, actually, Lorenzo. I actually think I just have that option, but it just doesn't work with every LTE provider that provides V6. For some reason, some of them don't do the right thing to enable tethering, and I haven't figured out the pattern, but I know it worked in Austria and Netherlands, but not in Germany on the same SIM. So on a German SIM, it worked in Austria and Netherlands, but not in Germany. So so a lot of that works, but I actually think that the use case is actually I show up in my coffin hotel, and I would really like to have all of the devices that they've given me in that environment to join my network. And when I leave again, that's the thing, that they go away. Now, there's other issues with how that could work, but on the routing side of things, right, increasingly we have people that don't have internet connections at home, and they're okay with the concept that their home is offline when their phone is not present, right? And so that's kind of is a, I think we should think about the stub network situation in that scenario where there was a 15.4 network behind a stub router in the Coffin Hotel, right? My phone shows up as the CPE router. I don't think there's any changes. Okay, I think it's just all there, right? It just there might be some some gotchas that we haven't thought of it.
Esco?
Oh, sorry, do you want me to? Oh,
You need to put yourself in the queue.
Yeah, so it just got me thinking about cellular in home. So there's one case that is getting increasingly common is to have cellular backup of your home router. So instead of having only a cable or fiber connection, you also have an additional cellular backup. So we might have to consider that kind of case. Where what if the home router / CPE switches to the cellular backup? So would that have any impact on the connectivity? We of course want to keep that connectivity for all the IoT devices or stub network devices that there are. So I think that's something to consider as well. Not just a user phone that takes that function, but an actual backup module in the CPE. Maybe there's nothing special we need to do for that.
Yeah.
Maybe there is. And by the way, it's not expensive cellular. I use it as if it's a free resource, and it's often faster than going to the Wi-Fi network of some place you are. So.
Yeah, I'm sorry if that's not the charter for the point. I mean, I wanted more than the array. What I was asking is probably that the devices don't effectively change their addresses. The one tethered to my phone stay tethered to my phone. They see only the phone prefix. The one, or they know the phone prefix. The one that are on my home keep the home address. They don't see the array from the phone. And they send the packet to the home gateway, but the home gateway is aware that the broadband connection is broken. It's aware that the phone is a plan B, and so it will relay the packets to the phone. If or that, yes. Can you read the original form? And yes, the idea would be yes if you want to pass.
You can't
State your name.
Lorenzo Colletti, you can't just have devices on the home network forward to the gateway and the gateway forward to the phone, because the source address will be wrong. They will be using the Wi-Fi network source address from the assigned by the ISP, which is now basically off the network, basically disconnected from the internet. And so it's just going to go nowhere. I mean, you could NAT it, but we should probably not go there. I mean, the good news is all the phone needs to do is send an array on the Wi-Fi network and it should work, right? Even the hosts on the Wi-Fi network that have IPv6 addresses from the ISP can like acquire a second IPv6 address.
Yeah, it's a renumbering scenario.
Yeah, or the multiple router scenario. It sort of works. I mean, like the multiple router scenario works when one of them is not advertising. When they're both advertising, I think, yeah, we don't really have. But anyway, yeah, that's just wanted to point that out.
Well, given that the last comments were almost out of scope, I guess we're done. Do you think?
Oh, we are done.
Thank you very much.
Check the notes and see if I misrepresented you. So you described yeah, the man
Yeah, well, got a little bit. Basically, I'm so behind on work from having taken vacation like a big loser. Right? We don't do that in the US. Yeah, no, it was very good. I had a great time in Utrecht. I got to ride in Oma Fiets all over the place and good times. Yeah. Yeah. All right. Well, I don't know. Are you going to be? I don't know if we're going to be in any more meetings.